Hello everyone and welcome back. So we are going to continue with our series. So in the previous video, we were talking about, or we completed the model evaluation component, and in the towards the end of the tutorial, we were having a challenge while trying to run our main.py. It was bringing out some error. So I found a way to solve that issue. So when we were building the component, under the component section, the model evaluation section, we forgot to include the set of these environment variables for the DAG-sub authentication. So that was the problem. That was the issue that was bringing out that error that we were facing yesterday towards the end of that session. So I was able to include this. So let me run the main.py. And after that, we can then push the code to Git repository. So let's run again the main.py. So main.py supposed to be Python. So Python main.py. Then I think it will. I've tried it, so I think it will work. Then from here, we can then push our code to the Git repository. So I think that was the challenge that we were facing yesterday. So before we executed the main.py, it was necessary for us to include these environment variables for the DAG-sub authentication. Because I remember we were separating the different components into we are clustering those components into their respective folders. So I think it was imperative. It was necessary for us to include these variables. So we execute that again. So it's going to take some time. Then I think it will run successfully. Then from there, I think I won't be doing the model validation per se, but I will make sure to include that in the next series, where we'll be doing a classification problem. So in that series, that's when I will do a model validation and probably include other techniques as other open source tools such as the DVC. We'll also, if time allows us, we will also include an CI/CD for the building a container image for that model. But that we'll cover that in the next series. So I think you can see as up to now, you can see now that our model evaluation component terminated successfully. That means our model evaluation component is executing as required. So technically, our code is running okay up to the model evaluation component. So I won't be dealing with the model validation as of now, but I'll make sure to include that in the next video. So make sure to stay tuned. From there, you will see how we can implement the model validation. Okay. So as for now, let me push this code to a Git repository. So git add post git add dot so git add dot. Then from here we need git status, just to see which files we are pushing. So git status So these are the files we are pushing, the readme, the config. Okay, just do cls to clear this. Then git commit. So git commit -m. Then from the git commit -m, we need to include a message. Then that will be a model evaluation complete. So with model validation, it was imperative for us to at least split our data into the training, the dev, which is the validation set, as well as the testing set. So the testing set will have acted as our validation. But when we did our train test split, we only included the training and the dev set. We did not set aside data for validation. I think that's why we cannot now implement the model validation. It will be similar to what we are doing with the model evaluation. Okay, I think we have pushed that. Now we need to do git push -u origin main to main. So I think that's it with the model evaluation. So let's start with the agenda for today, which is about us doing the prediction pipeline. So I'm just going to the predict pipeline. Then from there we can start with the prediction pipeline. With the prediction pipeline, so I'll start by import the necessary libraries. So numpy np import pandas. You can also import os. Yes, also import assist. Then from the src folder, we need to import the necessary modules. So from src, need the logging. So from see, we also need. We did prepare the exception, so we can also import the exception. So you can just clear whatever is unnecessary. The evaluation, we are done with it. So logging rule betsy, we are going to import supposed to be dot exception. Yeah, so dot exception, we're going to import supposed to be file operation error. Then load objects. So from that will come from the utils. So src rule betsy dot utils dot commons. So we are going to import load objects. Okay. So we are going to create a class for prediction pipeline. Create a class for actually handling the predictions. So the prediction pipeline for the prediction pipeline. Prediction pipeline. So and say class a prediction pipeline. So class a prediction pipeline. Then if needs, that's okay. And then for me, we'll just will not insert anything, so I'll just use the pass. Then we create another method. So method make predictions. So def make predictions myself. Then features. Self features. Then from here, I will insert the try block. So let me say the first thing, you can start with the log message. So login login.info, then we specify the message. So you can do something like making predictions. So after the login message, we start by specifying the model path. So load the training model. Let's first define the model as well as define the model and the preprocessor path, the preprocessor object. Remember the preprocessor object we created in our data transformation. So preprocessor object. So you can say model path. So we are going to load object os.path. Not fan of this. Let me use the os.path. Then our model is under the folder artifacts. So our model is this one here, artifacts model.joblib. So you can just copy the relative path. So .join, then we can specify artifacts, then model trainer supposed to be artifacts. Then we are using this the quotation marks to specify the path. Then this one will be the model.joblib. So this is the model itself. So the model is found inside the artifacts folder under the folder model trainer. So from the model trainer, we do have the model.joblib. Similar to the preprocessor object, we can just do the same. So this is the file path to our preprocessor .joblib. Okay. So after that, we can then load the preprocessor and the model object. So load the preprocessor and the model. So for the model, load object. So you can then instead of this, you can just use file path. So file path, then we specify model. Let me use a model path. So for example, here we can specify model path. So that is for the model, but let's start with the preprocessor object. So preprocessor object. So from here we can say load object, file path, preprocessor object. This one is for the model. Model path. Model path of preprocessor object. This is supposed to be preprocessor path. Okay, so preprocessor path, model path, preprocessor object. So preprocessor object, then model load object. That's okay. Then from here, we need to now transform the features. Transform the features. So features transformed, preprocessor objects transform the features. So features, these are the input features that the user will key in the web application. So then from there we do make the predictions. So model.predict. I think it is model.predict. Model.predict. Features transformed. Then we return the predictions. Then from here we can close this with the except. So except exception exception as e, then raise, since we are using we have imported our custom exception, we are going to use that. So raise file operation error e sys. That's okay. So the next thing after this, we need to create another class to represent the input features. So we need to create a class to represent input features. Input features. So for this, I've tried just to condense it. So instead of us listing all the features, so we are just creating a class custom data, and this custom data, what we are using will be to initialize the attributes using the quags. So again, we can get some little explanation from tab 9. So the selected code snippet with the custom data class of this init. So this method is used to initialize the attributes of the class instance using the keyword arg. So instead of us listing all the column names, we are just using the keyword argument quags. So so inside the init method, a loop is used to iterate over each key value pair in quags. So just remember, this will be representing the column names or the parameters. Things this will represent the column names. So I've not listed the columns one by one. Instead, I've just used this. Okay. So this allows the custom data class to accept any number of attributes. So these are the features that we are going to accept to use when creating an instance. For example, you can create a custom data object. Okay, it's given an example. Okay, so that's it about that. Then we are going to define a method to convert the data objects to a data frame. So the data that will be accepting the user data, we are going to convert that to sort of a data frame, and that way you have created this method to handle that process. Okay, so this is all about our this is all about our prediction pipeline. So I'm supposed to include this in the prediction pipeline. Sorry, this is the prediction pipeline. So the prediction pipeline does not contain a lot of things. So essentially, it's just to something I'm missing here. Preprocessor path, and it's supposed to be preprocessor path. So essentially, with the prediction pipeline, it's just to take the user input data, convert that data into a data frame. Then after that, we are going to pass that data through the preprocessor object, so that we can make sure that we are using the same preprocessor that we used to train our model. Then after passing that through the preprocessor object, we are going to now make predictions using our model. So that's what the prediction pipeline is handling. So it's something very short, but you can also include some things under the prediction pipeline. Okay, but at the moment we'll just be using this prediction pipeline. So I think I'm done with the prediction pipeline. Then I'm just going to commit this to the Git repository. So we're just going to add, I think it's just it's a status. I think it's supposed to be the prediction pipeline. Model validation. This one we don't need this. Anyway, so git commit hyphen m. Now we can say prediction pipeline. Then after this, we can do the git push. So it's push hyphen u origin main. Okay, so that's the prediction pipeline. So we are done with the prediction pipeline. So let's from here, I think we'll just move on state to I think we can create the Flask application, if I'm not wrong. Okay, so I think the next thing will be about the Flask application. Let me see if we are. Let me see if that was we are okay with that. So prediction pipeline. So let's go to our src. Go to src rule battery. Yeah, okay. We go to our pipelines. Let's see if we have updated our prediction pipeline. Yeah, I think we have our prediction pipeline. Everything is okay. So the next thing will be about the Flask application. So I'll be combining that with the prediction pipeline. Good. Okay. So Flask app. So let's go to app.py.